Hello. In these videos, we are going to look at how we can use parametric equations to find arc length and surface area. So first, finding arc length is ultimately going to come down to being a formula, but we know from our section way at the beginning of the semester of arc length that if we wanted to find the arc length in terms of x, we could find the integral from a to b of 1 plus dy dx, the derivative squared dx. Now, switching into terms of t, we'd ultimately have this u substitution that happens where x equals f of t, dx equals the derivative of t, and dx, the other way to write the derivative of t is dx dt. And that last line looks a little bit redundant, but it will come up in a bit. So we want to switch this to be in terms of t. Well, then our bounds will change to be alpha to beta for whatever t is when x is a and x is b. The square root of 1 plus, and then a couple videos ago, we saw that the derivative dy dx is the same as dy dt over dx dt. And now I'm going to use that substitution that dx equals dx dt times dt. To switch dx into t. And now some simplifications. This is alpha to beta of the square root of, I'm going to multiply everything by this dx dt squared under the square root, making a common denominator. So we'll have dx dt over dx dt squared plus dy dt over dx dt squared. That is a y times dx dt dt. And what we have under the square root, it's a really big square root, but that denominator is dx dt squared, which the square root of dx dt squared is dx dt, meaning these denominators cancel with this dx dt that's out front, or out at the end in this case. Meaning this whole integral is the integral from alpha to beta of the square root dx dt squared plus dy dt squared dt. And all this has done is show how we can get from our terms of x arc length into a parametric equation arc length formula. So we will use this arc length formula in an example in just a bit. But before we do that, we're also going to see what is then surface area. And surface area is going to get a very similar formula. That is, if we are going around the x-axis, and we have the parametric equations, x equals f of t and y equals g of t. Around the x-axis, we will get the formula s equals the integral from a to b of 2 pi g of t square root f prime of t dx dt squared plus g prime of t dy dt squared. So notice we have the arc length again, and then we have our function in terms of y out front. If we want to go around the y-axis, we're going to use s equals the integral from a to b of 2 pi f of t square root f prime of t squared plus g prime of t squared dt.